Okay. So, hi everyone. I recognize a few faces in here, but not too many. So, for those of you who don't know me, my name is Marie Boden, and I teach in the School of Electrical Engineering and Computer Science. I'll let you know straight away, my accent is Swedish. Otherwise, that's all you're going to focus on. And when I start speaking Swedish, James will be the only one who can pick up a few phrases now. Do you speak Swedish now? A little bit.
I can enough to understand basics.
Okay. Okay, I'll better make sure to not say anything bad then. There you are. So I wasn't sure exactly what to do here tonight, but I used to be part of a student society too when I went to uni in my undergrad. I did an undergrad I was a Bachelor of Science in Informatics, was the degree, what it was called then. It's quite similar to your computer science degree that you have here in the school now. That's what I did, and let me assure you, I slipped on a banana peel and ended up in that classroom. I had no idea what I started doing. I think that I was brought up in a very traditional environment, so girls just didn't do engineering. I didn't really think there was anything that I could do. We'd say, but I do know how to bake 7 different kinds of biscuits, because that's what you have for afternoon tea. But with saying that, I grew up in an area where they actually had Formula 1 racing. It was called Anderstorp, and it's so tiny, I think you can't even find it on the map, but it is there somewhere. So my dad used to take me to Formula 1 every year, and I got to actually meet a lot of the famous, world famous racing people then in those days. And also my dad's best friend was actually the European master of racing with a sports car in that division. So I loved cars, and I still love driving cars. I am not so much for playing around with the mechanics about them, but yeah, cars were really my big passion then. But again, that was not what girls did in my days, so I ended up doing something with computers, pretty much, just because I made a bet with some of my friends who told me that I wouldn't understand how to do computer programming. And being me, I of course said, I'll show you. And I did like maths, so that's why I ended up with those nerds teasing me like that, because I did like maths and I loved my algebra and logic pretty much, and that's how I ended up. So the banana peel was probably there on purpose for me. It turns out that I'm not the best computer programming languages. I think there's only 2 that's still being used today. Doesn't matter, because the other ones are really old anyway. But the thing is, what I did learn at uni, I have been making use of, and I think that the courses that I didn't realize until now how useful they are for me. But of course, the database theory, I tell my students, was the hate course I had. I really could not see that it was interesting at all, but then again, it's really useful, right? So I thought it was a very dry subject. My lecturer was hilarious, so he was completely into his database theory. He loved it so much, passionate. So once he was writing all the whiteboards full of writing, and then realized that he had used a permanent marker and couldn't get it off. And so he's standing there and he's scrubbing his blonde head with green marker, and he's scrubbing his bottom with his permanent marker. And then he just continued writing on the wall instead. So yes, I have really good stories from my lectures there. Now, so I ended up in informatics and doing my computer programming, and then I started realizing that I really liked how we humans are interacting with technology. And because the HCI was sort of the area that I found was something that I really fell for. How could people make use of this? How could we make computers for everyone? Because I am so old that the week that I graduated my bachelor degree, they finally installed the Windows machines at my uni, which meant that you could just click on it and you didn't have to use Unix or MS-DOS or anything. Like, you didn't have to use an operating system. And I felt a little bit like, oh my gosh, what did I do all that study for? But then I realized, yes, I can do much more with this. Everyone can use computers now. And that's what I got really interested in. And so I then came here to UQ. Again, I never really make good plans. I'm just a bit like, if someone suggests something, and I'm like, yeah, sure, let's do that. So when my husband suggested that he wanted to do a postdoc somewhere else but Sweden and go to another country, I thought, yeah, great. I love learning new languages and so on. I didn't anticipate to go as far away pretty much as you can get. New Zealand would be slightly further, but yeah. And all I knew about Australia was what I had seen on TV, and that's the Flying Doctors. And I had seen that Sydney show, what do you call that? Ramsay Street or something like that? Neighbours. Oh my gosh, yes. So I wasn't completely impressed, I have to admit. I was a little bit suspicious, but I thought, okay, we'll go for it. 2 years. I'm still here after 21 years, very long 2 years. But we came here, and so here I discovered that you can actually do a lot of computing, physical computing, and that's what I really, really love doing. But I have to combine my sort of background with my new exploration in physical computing. And so I thought I'll just tell you a little bit about what it's like, because I often end up working in interdisciplinary groups. That's sort of where my research is sitting, and it can be quite complicated when you have different backgrounds and different understandings of things. Are all of you electrical engineers? No? Mechatronics? All of you are mechatronics? Okay, yeah, okay, they mix. No one software engineering? Mechanical. Yeah, cool. Yeah, that's fine. That's all good. So I thought I'd just go through a little bit about the projects that we've been working on, because you do end up in teams everywhere, pretty much. And while we've been in bad teams, all of us, I'm pretty sure, still end up in those ones every now and then. You still sort of want to try to produce something nice out of it. And it's the passion of getting that good outcome that drives us in the end. And hopefully the bad teamwork doesn't kill us. So I thought I'll just mention some of the robotics projects that would suit. You said mechatronic, right? Mechanical. Okay, so you're the good car guy. Yeah. Well, we can have a conversation about that later. Sort of wondering what's happening nowadays with the cars, because they're so digital. Yeah, they are. And so I have a few robotics projects that I thought I'll mention, and also I'm going to talk, just show you some of my favorite physical computing projects that we've been doing with students. So the research I do is primarily focused around how we can actually support teaching and learning. Again, I'm not sure how I ended up in that space, but that's where I ended up. And I think it was my frustration of seeing my children being taught the same way as I was being taught when I went to school. They had the spelling test once a week, and I could not believe it that they had to go home and they had to write out the words every day, and then by the Friday they are tested, 10 or 20 words. And there were kids who were completely refusing to do this. And so then my husband asked me to help me give an input on an article he was reviewing. So my husband's a computer scientist and professor in bioinformatics here now. But he gave me this article, and I was like, are you kidding me? Why am I reading this research? And then when I read it, he asked me for my opinion, and I said, well, I think this is quite a cool idea here, because it was an AI-based system that was helping people to train for doing just typing on a keyboard. But I said, why would you waste such a good system on just typing on a keyboard when you could actually use it on curriculum instead, and have the computer helping to choose different tasks for the students to actually do then, and getting them at the right level of difficulty. And so my husband then, of course, again knows me, so he says, why don't you build that, Marie? So that's what I did, and that turned into my PhD. So I built a system for training spelling, going away from the old way of doing spelling in school. And then I created this system, and I realized there were different kinds of AI systems, so I I actually created 2 systems, but the kids didn't know. They were just seeing one front end. But at the back end, I had 2 different AI algorithms working. One was just based on the 10 last attempts the kids have done, and then the system chose a new task for them to work with. So they should be able to spell 4 words out of 6 words correctly, and 2 words would be a new challenge for them, and eventually it would move them up. So I turned it into a little game. And I compared that with a much more advanced model where we did a student model of it and looked at how could we compare them, and etc. It turned out it was a much bigger job than I thought, of course, and that's why it turned into a PhD. But in the end, it was quite a fascinating work to do, because you could actually change the use interface so that the kids were really engaged. And rather than all class protesting against having to do the spelling, the kids actually got really involved. And because we had turned it into a little bit of a game, there was a reward system in there, and so they could actually enjoy it. And they felt like they were amazing spellers. Some were amazing spellers and working on at a really high level, whereas there were kids who were struggling, but they were working maybe a year or 2 levels below what they normally would. But because they were playing this game, they felt really successful, and therefore they improved their spelling. So the educational environment has become the one that I'm sort of become an expert on. I advise for the national and for the Queensland curriculum here. They sort of pull you in every now and then when they need some advice in there. And I also do a lot with social robotics. Having humanoid robots in the classroom is what we look at. But the themes that we work with mostly is around sustainability and computational thinking. I've done some stuff around mathematics as well there. And the tools I use are microcontrollers of all kinds, and AI and sensors, of course, and co-design. So I like to design together with the people that we are working with. So OPI is a project that started in San Diego at the University of California, and they wanted to have a humanoid robot in a classroom for really little kids. Do you remember when you were in preschool? Yeah, it would have been cool to have a humanoid there. So I got called in a little bit later. They had a team already when I came in that consisted of psychologists, engineers, and educators, like teachers, and then they needed an interaction design as well, and that's where I am from. And we pretty much fought for 4 or 5 months. We had a big team, and it was rowdy meetings, and people were angry and stomped out, and etc. But we still persisted because everyone was really keen on building this humanoid robot. And it was really funny. So we had the psychologists who told they had made sketches of the robot that they wanted, and then we had Pauline Pounds, who was one of the engineers there, and saying, "Yeah, that will only weigh 20 tons." and it was like we were not meeting in the middle at all. And after a while, after a few months, we figured out that prototype, for instance, is a word that I think for you means it's the final produce before it would go into production line. That's how Pauline viewed it at the time. And me being an interaction designer, I had a cardboard with a fake interface and Wizard of Ozing behind there, and just testing out how would the kids actually react to it. And then we had the educators sitting there with the iPads. A robot for them was an iPad. And oh my gosh, before we could actually get the terminology around us then. So that's what we really were focusing on. And then eventually we started working together. So some people would work more with I called in some more interaction designers because we needed some more designers there. Whereas I started working with Pauline, which was brilliant because then I got the fun part of actually being part of building and playing with the sensors and everything like that, which I thrived in because I learned so much. So we actually came through with 5 iterations. This was the version that we took to the classroom, And we cut off the legs. We quite quickly realized that a walking robot in the classroom with kids who are pretty much the same height or just slightly taller, they will just grab it because they want it on their own. The robot falls all the time, yes, and it breaks, the sensitive. And so now robots break all the time. Hopeless, let's put it that way. So we decided to have a stationary one. And of course, the first time we brought it in, it was also quite funny. We had kids just running up to it. There were like 20 kids, all of them wanting to hug the robot. And it's not a very huggable one. So even though we had put padding on it and so on, I mean, it's not very soft and nice and so on. And the head's definitely not huggable. We did put 2 screens in there, so we did realize that we needed eyes. So we had the psychologists who had been testing it out. And one of the versions we had where we had a really lovely interface that the kids loved. But then there were some ideas. No, we need to have a mouth then, we need to have teeth, and I don't know, everything. Everything was put in there. And then the psychologist brought it over to daycare. And we had kids screaming, running out. And parents being very, very angry afterwards. So yes, we have really had all the versions there in what you can do. But what you can learn from this is that when we are sort of teaching, so they put me to teach design thinking at the moment here at uni, which feels a bit like a soft subject, but it is quite useful in the end. But the methods we are using here and that we have tested is like we did the worst possible idea. The interface that would just scare away everyone, so we could take that away. We did really try what worked best, but slightly boring. We did try out several iterations. So we had 5 iterations of like low fidelity or mid fidelity prototypes before we even started building on our final prototype there. Now the final prototype has turned into an absolute scary one, and no one talks about it anymore. It's hidden away in a cupboard. No one wanted to. As soon as we finally had that one, it's a bit of a shame because we had so much good fun going up to that place. But and it's really interesting. But we did get some very nice working teams out of it. So we had other products coming out from there as well. So this one was with the US, San Diego. And so Pauline has continued working with the iRat there because they had a little robot rat that was running around in a maze, and they were trying to understand how rats are finding their ways around. So it's really a project that started with the AI here, and where we're trying to optimize how actually you find your way around. And Pauline then decided that this robot rat didn't have whiskers, but it's actually the whiskers that helps the rats move around in the little tunnels there. So it's the whisker that comes out, and that senses the walkway that they get through there. So we got some really nice projects in there. We learned a lot about how to actually work in interdisciplinary teams. And in the end, we did not fight anymore. We went to New Zealand, we went to a robotics conference there and presented, and we had an awesome week. So yes, persist, even when it's really hard work in your teams is what I would say as advice there. But also take the time to really talk through, because sometimes we talk and we think we all know that we mean the same. But what happened was that we actually were talking about different things, and that's when the big bang happened in one of the meetings. So it's good to know that even the researchers here are having these interesting conflicts, but we worked it out. So it was nice. Another robotics project that I worked on is also with the humanoid robots. So we had the humanoid robot, it was called. They didn't have any humanoid robots in classrooms here in Australia at all at the time. So there were some people down in South Australia who got funding, and they bought 2 now robots. And it was actually a project that was done with educators, like researchers in education. But then they needed someone who had a little bit more technical skills and who had actually used robots in a classroom. So I used to do a lot of programming with robots and things for high school students for a while. That's how I pretty much learned about robotics from the beginning. And RoboCup Junior, that's how I got into that one. But So I got called in. It turned into a really big project that went national eventually, and where we started off by just placing the robots into classrooms and saying to teachers, we gave them a one-day training on how to work with them, how to program them, and then we said, do what you want with them. And we then studied what happened. And that was really interesting. So often the technical teachers decided that one humanoid robot is not enough in a classroom. So they just put it aside and didn't work anymore. But then we had one of the schools where this had happened, and the kids in the preschool had asked about this robot. It was named Thomas in that school. And they asked if they could actually meet Thomas. And so the teacher was like, I don't have a clue about how to do this, but let's bring it down. And got the technical teacher just to show her how to actually program the robot. And the kids got so excited. They saw it as a disabled person, which is a bit weird. They loved it. They thought it was like a classmate, but that classmate needed a lot of help to understand. That's how they viewed it. And then they were like, we want to program Thomas. And the teacher, I mean, these kids were 4 years old. The teacher then said, okay, let's do it. So she actually took screenshots of the icons, because it's an icon-based little programming language for now robots, and you have to just wire up the sequence of how to actually give the instructions. And then she realized that in the curriculum they have to do needle threading. So she had red thread and needles, and she had them actually gluing together the sequence of actions and needling it together. Then they took the sheet with them, and they walked up to the big kids in year 1. So the year ones then sat there seriously with their computers, and they programmed the sequence onto the laptop, and then together they tested it out. And then they actually got a really good flow. This is a girl not from kindy, she is from year 5. And in that classroom, they decided to really go for the programming and getting them a bit better on how to program robots here, and understanding how you sort of program robots, and because it's a really good way of learning how to actually break down problems. So people who do mechatronics and robotics and so on, they're really good at problem solving, that's for sure, we know that. So this girl, she was hilarious. She actually taught the robot how to clean a toilet. And she learned a lot about physics as well, because they have, in the programming language, they have the, a simulated robot. So it works perfectly on her simulated robots. But then when she tested it, the robot dipped. She tested it at home at the toilet, and it dipped. So yes, hard lessons learned. I don't have a video of that. I wish I did. We actually had the humanoid robot project going to 10 different schools in South Australia. And one of the best findings we had was that by having the humanoid robot and computer programming with Python together with it, we got teachers who had never ever done computer programming at all before having to teach this subject. And they actually turned around how they were teaching, because they didn't know it. They couldn't answer the questions the students had. So that students came and asked, but how do we do this? And the teacher would have to say, look, I have no idea. But because the teacher didn't know and the students wanted to do it, they were supposed to learn, and the teacher was as well, they just would learn together. And therefore the students got even more engaged, because suddenly the teacher was learning together with them. And so they changed the whole way of teaching at that school because of that. That's pretty impressive. And also we took it to a school where they had a lot of Aboriginal people. And they purely wanted the robot, it turned out in the end, because they wanted to attract students to come to school, to just attend school. But the kids got really excited and then decided to teach the robot how to speak their native language that they had down in Maitlands there. And so they actually learned to do the computer programming, plus they learned their own native language. And they also started understanding how they could actually program a robot to speak that language as well. So yeah, they were pretty good learnings for education. That's good. Not so much about the robotics there. So, like I said, I really like when we go more hands-on. And so this is a project that we've done just in the last 2 years, and that's called Study Fresh. And this one has been about measuring air quality in classrooms. So it is a citizen science project that the government wanted to find out about the air quality in classrooms here in Queensland. So they funded it. But when we started doing this, I was like, so we actually created this one. So there's a microcontroller in it. We got a temperature measurer and CO2 measurer in here. And then we placed them into the classrooms. And we just measured the air quality in there, and we reported it back to the governments. But then I was like, the kids could probably build this themselves. So we created a little kit. You can have a look at that if you want to. Yeah, please ask me, because
what's in the UQ classrooms on the roof? Because I've noticed there's a few like Raspberry Pis that are sort of scattered around some classrooms.
Most ones.
Different ones?
Because after our data came in, they actually decided to do a bigger study of it.
Oh, okay.
So yes, so we triggered that probably. But it was a fairly small little project from the beginning, and it turned quite big in the end here. But the biggest thing has been that we actually have got the Study Fresh project here. So we created the kit of how to put together that one. And so you can see here, we bring it out to school. So this is actually from 2 weeks ago. I went to a school, and the kids had to wire up and setting up with the sensors, learn about how that works, because they have all these things in the curriculum, but many teachers are feeling a little bit insecure about how to do it. And I don't know how much you got to do when you were in school. Yeah, a circuit is as far as I got pretty much. And remember, we learned about circuits. We had to hold hands and close the circuit, and that's pretty much it. But these are kids, they were in year 5, 6. And what we did was that so once they had done the setup, and they had it all running, and we sort of taught them all about that and creating the circuits. And it's a Raspberry Pi that we use. And then we had to go around and check, of course, that everything was right, and then they plugged it in. And then we taught them how to program the Raspberry Pis in Python. And one of the tutors, who's a student here, he nearly cried. He's like, do you know how much I struggle to teach some students about the Python coding here and how to just go through the operating system? And I mean, we're all different. So it's like, it depends on what we're interested in and so on. But these kids were amazing. Like, they just followed so well here, and they got really good at what they were doing. We did have very fun activities, so I actually suggested we should bring some of the fun activities for understanding operating systems to our students too. We could do that in a week before they start here or something. But just having a play about it, because I don't know about you, but when I came into the room the first time and they just tell you to do this and that, and I was like, hey, I have no idea what you mean here, because I have not been playing with this before. But we learn, don't we? And then it gets better, and then we forget about all the terminology. Yes?
So those kits, I might miss this, are they made within like UQ?
Yeah.
The program, is that in your research area?
Yeah.
Is that the same with
You can borrow them.
Is it the same with that thing as well?
Yeah.
Yeah, that's awesome.
Yeah, that's part. Yeah, it's students who actually design them. So I just supervise them. I do like getting my hands in. They probably slap them sometimes and say, leave it alone. But yes, so I now have one thesis project with a guy, and we're looking into how can we teach these kids about electrical vehicles and power. How do we actually make the most out of the power in the batteries in the cars, and how do the cars work then? So that's what we're working on at the moment. I think it's a really cool little project, and I'm hoping the kids will do too. But in the end, I mean, that can be used, so you can use it as promoting our degrees, because I feel like students don't know what to choose. Like, there are these degrees and so on, but we don't know what it means exactly, because they don't really get the experience in school. Some schools are amazing, but some do less, yeah? So whenever someone is interested, I would love to do more. But I think you created something nice. You borrowed my Arduinos. Didn't you do an Arduino workshop here? Did you create something? Yeah?
There was a KeyCAD, we're talking about like KeyCAD trying to design a PCB using some existing thing and then how we go about doing our own PCB.
Okay, you're not using the Arduinos for that, are you? No. No, that's not the same. Yeah, no, I didn't.
I was in a workshop a while ago.
That was also on
Okay.
just making sure like
I do know I spoke to, was this Royce, was he involved in this project?
Sorry, what?
Royce was involved in this?
No, Ross has never been involved in this.
Royce.
Royce has, yes.
Yeah,
Yes.
no, he was involved.
Yeah, Royce was part of it.
And he did his thesis on the micronumber code with
Yes.
younger,
Yeah.
I read the thesis.
Oh, you read his thesis?
Yeah, I read the thesis.
Yep, yep, I supervised him there.
Yeah.
And that was a nice one. So he actually met up. I think we had Tim on one of the photos before, didn't I? Yeah, here, see. This is Tim.
Oh,
He,
oh, what, this is him.
Tim Hadwin.
I knew that seemed familiar. Yeah, I was the guy on the left.
I think he ate more chips then.
Can you send us this photo?
Oh no, I loved him. I'm not gonna be that. I'm not sure I can tease him like that.
That's all right, we'll do it for you.
He and I used to do the C programming workshops for Robocup
Yeah, so
robots.
the left went, he seems familiar, don't know who that is. I ignore the guy on the right.
So Tim used to, so I did a lot of outreach workshops in those days when I did my PhD studies here. And Tim was one of the tutors that worked with me. And we used to discuss, like, there is nothing good between the going from the icon-based with the NXTs there into proper code-based programming. And so, yeah, now it is. Now we have something really good.
That's how microdevelopment.
But he was completely into designing his robot at that stage.
I've seen all the other
But eventually, the complaints there came through as well. They're good. They are. I think they are making a lot of money on gambling devices, though.
Yes.
Oh, he's not going to listen into this one, right? Okay, well, so amazing is like the study fresh has been fabulous. We've had 150 schools pretty much that we've gone to, and we got this started. What I like to do, I don't like to do just the short 45-minute sessions. I like to go in and have an idea for a teacher on how they could actually work for a whole term with it. I just want to start them up, and then I want to have them problems they can keep working on, and the teachers can actually make use of it and do the assessment and whatever they need. So it fits into the curriculum, and hopefully they do it again next year. Because if we do that, then we're going to get more students who are going to get excited and knowing what they're choosing when they come to uni as well. But most of all, because it's fun, right? So Study Fresh is really cool. But like now, I'm feeling like I've done that for a couple of years, and it's time for something else. So electrical vehicles it is at the moment. If you have some ideas, please come and let me know. I thought I'll just finish off by mentioning a few. So I say I like physical computing. So I used to tutor that course. I think that there were less rules when I tutored it. There's so many OHS rules nowadays. And I got into bad trouble for walking into the workshop on a Friday, late Friday afternoon, when I needed to just get a tube to put my poster in to send to a conference. But I was in sandals. No one was in there. Nothing was happening in the room. It's late Friday night, and I'm walking with my sandals on. And on Monday morning, I'm called into the head of school office with my discipline leader standing there, and they're both looking sternly at me. And I was like, okay, I'm in trouble. I realized that. I just didn't know what. And they showed me a video of me opening up the door into the workshop and sneaking in like this and picking up a tube, and then I'm out again. That's all I'm doing, nothing else. And this has been sent from the OHS people who have been sitting on Monday morning watching these videos. So there we are. I complained and said, I'll wear boots next time, but what kind of outfits do you need to wear? It doesn't talk about that. We'll see. Okay, so physical computing is really good fun because we get to have a bit of play around with computing without having the technologist like a laptop or keyboard or mouse there. So I like it. You can hide it. I really like smart houses. We'll talk about that later. So physical computing, the students get to do projects. They get to create fun things. So doing like another method that we use in design thinking is about we can make it minimized to test out and see what affordances there are with that, or we can go ginormous. And these people decided that they wanted to go big. Is this gonna show? So they built a giant sling, and you can see the red button there. And have you seen the FISComp IXD exhibition here at uni? It's up at Liveris nowadays. Yeah. So when we did this one, we were at the library in the city. And so we actually put it up there in the big hall. And people could come and try it out. So they had a gyroscope in the sling there. And they had cameras picking up how people were moving. And so they got the gestures in there. And then they created a touchpad underneath the red button, because they didn't find one to buy in those days. So they actually created one with foil and some foam in between and cables there. That's what we used to do for sensors in those days. It broke that night. We had a lot of visitors and everyone played with it. They wouldn't stop. In the end, people just sat around the big hall there watching the game playing. I think we should make that one of those and have outside of GP South, but we should actually have the slingshot for shooting off the recycling and sorting it. That would be cool. So yeah. Turn that off. So these, yeah. No, this is not a thesis. This is a group project in the physical computing course. It's one of the DECO courses. But the thing is, like, what happened here, so Tim actually did that course. So he did an engineering degree, but in the end he made sure that he went through a lot of trouble to be able to do that course. But he really enjoyed doing that physical building and so on. And when you get people from the different backgrounds, you can do some really cool stuff. We always found that when we have those groups where we actually get the different specialties in there and they come up with a cool idea together, they will make really nice. I will admit, this group was not our best group, but they had a really good idea. So technically, they were not the strongest. We had to help a lot. That's fine. My colleague rewrote the whole code hours before, and I had to create some new sensors, and that's okay. But the idea was really, really cool there. Yeah. So that was a group project in the undergrad level.
Is the slingshot still around, or is it long gone?
No, it's got long gone. We have had some really fun projects that have disappeared. Most likely because the OH&S has sort of thrown it out. We used to have, you know, what's it called? When you have the spinning blade and you spin it really fast, holograms. Yeah, you know how to make a hologram? Yeah, you have it spinning. So we had one who went ginormous on that one too. And it was placed in the, what's it called, the building down the end here? Pardon? It's James Foots, yeah. So you know, there's this big high ceiling there between the two levels. So this spinning blade went from the base up all through. Yeah, and the thing was that the students were so excited about the ginormous hologram that they had created, and it was really, really cool. It was also for FISCOM. It's just that they forgot about the security parts of it. And we were having people externally coming and visiting and so on. It was a fun course to teach, like, that's for sure. But it was a lot of problem solving happening in that one. Okay, sorry. And another one of my favorite projects from FISCOMP is that we had this team who wanted to actually create like a collective experience of seeing photos from Instagram. And so they created this physical table. So it's just a table and they cut a hole in it there. And what they did was that they put a gyroscope underneath the Pilates ball, and then they put a camera and a projector on top of it. So the projector is projecting what we can see on there, but the camera could also see how we were moving the globe around. And so when you had, like, let's say we had Sweden at the top of it, it would pull out pictures from the city or the country or wherever they were from Instagram to be shown around here. Now, they had to fake it on the night of exhibition, of course, because when you do that, you will get pictures that are not censored. And so we had to fake it, of course, for the night. But the thing was that when the exhibition was on, the SAP was visiting, and so they actually invited the team to come to India with them. And they competed there, and they won the first prize on that one. At that stage, they had changed what was actually being shown, so they showed statistics of cricket instead, so you could go around, because they had to do a big show on there and so on. Yeah, it is pretty cool. I mean, we're talking about when we still didn't have as good technologies as we do in social media today, but I like it because the physical computing of it and having to get the sensors and connecting with our microcontrollers and getting the old systems together, it's really, really great fun. And you learn so much from it as well. Also, this one, it was called Globe Masters, but then that one also, so from my research, I was like, okay, I can use that. And so we took it to a classroom and we turned it into a learning tool for children in year 3, because they had to learn about climate changes that we have the year 3, and actually, physically, the brain of a child is not always developed for understanding complex, abstract issues like climates around the world. Many of them have only been sort of in the local area and so on, maybe traveled a little bit in Australia, but not knowing about the rest of the world. And still you need to understand climates around the world. So the teacher was talking about how difficult that was. And so they asked if we could sort of come up with a way of complementing how they normally taught it. And that's what we did. So but we turned it into a bit more like they had to figure out some different challenges in there. And so we put some stickers, so they got animals and plants coming there. And they started discovering that the same climate was happening around the world, but with different animals and plants in there. I have lots of projects, and I feel like I should have shown you more videos. Unfortunately, I don't have them, but please ask me more questions. I just thought I'll finish off by, as you can see, what I'm looking at is like, how can we actually come up with new ways of teaching and learning without having to just use the Microsoft suite here or internet like as per se, but can we do it in an interactive way? And because teaching often happens with groups together, and that's what I also look at. So how can we design it collaboratively and so on? I thought I'd finish off also by mentioning that we have the National RoboCup Junior on the 19th to 20th of October, and we're going to have Asia Pacific RoboCup, which is for uni students. Are you going to put up a team? Anyone thought about that?
Which competition?
For the RoboCup, the Asia Pacific one.
Yeah, which division?
So I'm not sure. Well, you can have my 2 now robots, but they're not working at the moment.
There's the at-home one, which, not to put in front of
I think there would be a soccer one, for sure.
And I was saying, a lot to get home for. I know lots of universities they don't give you the hardware for that one, and it's more less like it's more human. I guess it fits more well with your research line as well. Okay, some of the soccer ones, but where do you know where that is this year? The road to Asia Pacific. Is it in?
The Asia Pacific?
Do you know where it is? As I don't know.
I think it's going to be at UQ Center. That's what Margot said.
Oh, they're combining it.
Oh, that's why I'm saying, do you want to put together a team?
Right, I get what you're saying now. Yes, yes.
Yeah,
I'm very interested. There you go. Yeah.
that's what I mean.
Yes. No, that makes sense.
Oh.
Volunteer though.
Or why don't you bring back the micro mouse?
We do.
Oh, you are?
It's in January.
Oh, cool. Are you going to run it here?
Yes, it'll be in West.
Oh, that's the first thing I saw when I came here, and I'm completely sold. That is so much fun. And the challenges in there is really great. Yeah, there you are. Oh, well, so if you feel like bringing some friends coming around, we had good food this year. We did the States.
Very, very good. It's a lot of fun. Everyone should volunteer, even for a day. And you get to, it's fulfilling as well to see the students perform. And there's also, it's a national one, massive. And there's also beauty companies there as well. You can talk to throughout the day.
Yeah, and we're gonna have more companies there this year as well. Well, I didn't put an effort for the Queensland one because I felt like they don't want to go to 2, so I'm gonna put them all in for nationals. We're just gonna wow them. It's the plan. That's what we like doing. Yeah.
And it's pretty cool what some of these high school students can do. Like that robot there, that was
Yep.
A team from Churchy, grade 12 kid.
and Church Grammar, and they said that's one grade 12 that's red level guys, and they came 4th in internationals, and that robot's very good and very quick. And,
Yeah.
it's
They're
cool.
pretty amazing.
Yeah,
Yeah.
it's incredible.
It makes you feel a bit like, what was I thinking when I was that age?
Exactly right. And they're all lots of this.
But also, if you want to come up with some cool ideas, because I would love to see some cool projects around uni. I think it's a bit sad that we could have something more, like the drinking fountain, we should have that in. We could do something more fun with it. Yeah. Or recycling garbage stuff that's being thrown.
Rebecca Back Home, I think, would be a good youth project, which I know lots of universities are already doing, and I know that could. I know it takes a while to get started, but lots of good resources out there.
Yeah.
For the software challenge, but it's a lot of
Logistics League might be good as
league
well.
as well. Yeah.
Also, if you would like to have a booth at the Nationals, I'm happy for you to do that too, of course.
Yeah, it'd be good march
Have a think about it. I don't want to put any pressure on or anything. I mean, it's a weekend, I get it. And I was completely knackered on the Monday, I have to admit. But it is very, very nice. It is. Yeah, the kids you'll be like an idol. Anyone who's a uni student, they'll be like, oh. So it is fun, it's quite rewarding. And we are stuck with the national RoboCup Junior designs, but I am, of course, being creative with them as much as I can. So I'm thinking about having them hiding and peeking out from the logo or something like that. That would be cool, just making a little bit more extra fun. So then you have a special t-shirt. We can't pay you, but we give you lots of food and we give you lots of sugar and t-shirts. Yeah.
And the shirts, are they going to be purple and lilac this year?
Yeah, that's what the talk is.
Excellent. You have an awesome purple shirt as well. Best
Oh yeah, better than. Oh, sorry, I shouldn't say that. Oh, that's such a good idea. Why didn't I think about that? Maybe I'll tell Margot we need polos, but nice cotton. Yeah. Okay, we'll see. Cool. That's it for me.